So, what we have here is an old radio which I got. It's an ITT SCHAUB Lorenz Stereo 5000 HIFI radio from 1966. When I got it from the store, it was in its original packaging. Means it didn't have any major damage on it, except for maybe this corner right here. That's it. And what I'm gonna do to it is, as you can see, I've opened it up, and you see this is really an old style type radio with all of these condensers in it. These are condensers. They're made out of aluminium casing without any plastics on the outside to create a backwards compatible cell function with higher frequency bands. So what does happen to these components is, when they get hot, there's wax inside of them to keep the innards from coming out while they're in operation. And the innards are containing aluminium foil, first of all. The second, some sort of dielectric, usually a mineral oil. Third is some type of shielding material, which is carbon, or it could be carbon zinc. And that's it. And what happens to these when they get hot over a few years, several years rather, hopefully, the wax starts to protrude from the outside on the side of the condensers. So then they lose their nanofarad capacity, and you start to getting static on the line, or the line not working anymore, or working for a while it's warming up, but then when it's warm, cutting out in between. So I have the guts to find a way to protect these more than, because if they die, I have to get them from somewhere which still makes these parts available. And I'm not sure that there's many of those manufacturers left. There's also transistors on the side. As you can see, it's an old style transistor type. So. But the thing is, there's nowhere a serial or record or labeling number to be found on these anywhere. So I need a little help. So it's for 4 ohms impedance speakers. 4 ohms, which is odd for that year. No, it's green, marked with the green dot. Any others marked with the green dot? There should be a lamp in here, and it isn't in there. Another green dot right there. Green transistor type, NPN. Well, there's no mark here. There's a mark there. That should... What the hell is that? Is that a grounding effort? The orange cable you can see? Is it a grounding effort? Ah, it's per channel. It's to ground the casing of the speaker, which it fires, I think. No, of the grounded material, or maybe the external filtering device which you could plug in. See, it has the availability to have a crystal filter installed in there, which is quite remarkable for those days. These days you start talking about a crystal and everybody just logs out and has nothing more to say about it. But it was very, very sophisticated technology for back in the day. Too bad that it didn't come with a crystal box, with a crystal filter set, which we could try to use. But as you can see, the radio is in immensely good condition. It's like it was never used. There was no dust inside of here anywhere. The original mounting and it had isolating tape on it so it wouldn't have any contact with the outside air. Now that is going to be a problem, of course, because it creates a pressurized temperature field in here, which higher the temperature goes, the less the life expectancy is of your components inside here. And also this board was mounted in, but it's as you can see, if I push it, it's loose, totally loose. But it doesn't. It has capability for. It's like it's been slide out the rail here. I don't know. Maybe I could get it back in, but you know, it's a. Slide this out. But then we get the dial sensor here, and the dial. You can try to get the dial out, but why the hell should I? Could try to get it in like that once my special coating dries, but I'm not going to tell you what the special coating is. I'm just telling you it's coating which I put on there. Also the actuator which the long wave bandwidth band uses to cycle through the band 9 meters from 40 to 49. It used to have a cable just like this one, and this cable, this is the FM and AM range cable for the dial to slide over the gauge. This used to have a button just like that on the side. I'll show you here. Right here, the LMK section, and inside of it, it has this rotary, this axle and this rotary. And this rotary is kind of heavy, so it has more inertia of mass, so you can spin it faster and better. But what's happens then is this sits in here and operates a cable, which is at the end here, strung up, and it's strung around a pulley which is connected to this device, and that pulley and the cable then leads to one of these cables you can see right here, which initiates a dial movement as well in this range over here. But that had to unfortunately be disassembled, because when I bought the radio you couldn't move the dial. It was like this mechanical thingy was what's locked up. And I don't know what the problem was. Maybe the fat in there turned into some sort of resin which hardened out, so it was mechanically very, very rigid, very, very tough to move. But I took care of that with some spray and a lot of twists and turns. There's 3 cycles, 3 full spins is a full cycle of the band between 40 meters and 49 meters. So what I did was I got this out, and instead of that I have this which is locked into it, and you can see I can move it. So it makes the availability. Yeah, I can move it, but I have to find something for this, just to use some tape, but I can move it still here. So the 9 meters of band can still be walked through. This way of nudging through frequencies is something which takes me back to the early MASH episodes, where, you know, the guy Radar, is the radio guy, he had these dials, but they were extended to the outside with a twisting handle, which he had to twist when he had to go cross nations. You had to twist that and put a cable into the bypass section to have contact with HQ. It was formidable. When I saw him turning that wheel, that was interesting to me. Of course, I'm gonna have to do something here. I'm gonna have to cut this out. So the ITT SCHAUB section has to be cut out, because I'm gonna have to turn this thing by hand. Of course, it also has this aluminium plating, which is weird, because everybody knows if you send a radio signal which is directed at this section, and the part is aluminium, which protects it. Aluminium repulses that wave, but it repulses the wave in two singular directions, which is up the way the signal comes in, the vector comes in, boop, and the vector goes out. Boop. So when the radio wave, which is modified to do that, enters it, it has these weird jittery pattern-like frequency signals which could bump into any one of these components and cause major errors or faults or static. To prevent that, I'm going to use this sort of tile here, just some sort of weird fake porcelain, and I'm going to capsulize in all of these condensers that are on the top, and this heavy one, I've got the setup right here. This goes here, this one goes over here, this one goes over here, this one goes over here. Then again, you see this line here, that's the base circuitry, I think it's base circuitry line for this transistor on the back. On the back. Now, if I draw out the circuit diagram of how a transistor is supposed to be switched up or made up, I'll probably be able to tell you if it's an NPN or a PNP transistor. But I've never seen this before. I've never seen a condenser in series with a resistor on a line, except for the emitting circuit. I've never seen that happen. So anything that is multiplied by the multiplicity effect, it has to have some sort of impedance, an extra sort of impedance because of these condensers, it charges up and let's go, and it charges up and let's go. It's not completely constant because all of these components, they're DC current rated, so I don't know what that does in DC, but I haven't made up the diagram yet, and I'm not that smart that I'm gonna have to do this in 1 minute and I will tell you the answer. No, I have to really draw it up